Well, it's very impressive to be here today. Well, I'm Dimitri. I'm a PhD student from the University of Nantes in France, and a contributor to RozoFS, which is a scalable distributed file system, and one of its main features is to rely on an erasure code in order to protect the data. So we'll deal with that, and let's talk a little about the distributed file storage. Well, everything starts with the question how to improve data protection or data performance of my storage system. And well, red appeared to be a solution. Well, it's a good solution in computers when you reach the limits of your resources, of your available resources. It's complicated to go further. So today, what is common is to distribute your data across a set of storage nodes, and when you reach the limit of the system, you just bring the new nodes in the network and you improve well, the global resources growth. Okay, so we have a solution that do that in an efficient way. Well, provide a unique, RozoFS provides a unique namespace, meaning that you can access your storage files just like you do usually in, well, in your computer. I mean, everybody that's joined the network is able to mount a file system which rely on different storage nodes, on a set of storage nodes. And provide scalability, you can grow the system, flexibility, you will see that, because RozoFS is composed of 3 components, and you can localize all the services. Heterogeneity, meaning that there's no other consideration, specific other consideration, because you can install it in commodity servers. Access, the access to data, transparency, and it's and what is really the purpose of this talk is data protection. So, let's see how it is done here. Okay, so the fault tolerance is usually done like this. We write redundant information across the node of networks, and when you want to read this data, you actually read a subset of it, and it's enough to get information back. The point is, when you have a failure, well, it's inevitable. Failures can come from the node, from the link, or any other consideration. When you get it, you just put that information from another node. The traditional way to do that is to replicate data, meaning that if I want to store a file, I will actually produce 3 copies of the files and distribute these files on the nodes of my network. And that's okay, but it's fine, there's no huge complexity here, but you actually store 3 times the amount of data that you actually need. So what's the problem with that? Well, this is a curve extracted from a report that it wants to alarm about the fact that the amount of data is really growing a lot, and one of the points is that data protection plays a major role in this fact. So okay, what we want to do is to find a way to reduce this storage consumption, but still providing data protection. So what we propose is to use erasure coding, which is an alternative technique to data replication. The idea here is when you want to store a file, you actually cut it into k data blocks, and using a mathematical tool, you are able to compute redundant information. So from the K data block, I create n parity blocks. Then when I distribute these parity blocks on the network, I am able to reconstruct the former information from any K subset of the parity blocks, meaning that I am able here to face two failures, and the point here is that the storage overhead is only 1.5, so it means that I actually provide the same data protection that using data replication, but I store half of the data. So this is really great. Problem is that usually region coding brings complex computation. Because depending on the tool you use, encoding and decoding can be very, very complex. So we propose to use the Logit transform, which is a mathematical tool long developed at the University of Nantes. And it is formally, it's used for a lot of application and formally used for medical tomography. So it's very convenient to go into discrete geometry tool. And okay, the purpose of it is to compute redundant information from user data. And the particularity of this tool, this mathematical tool, is to provide redundant information only based on addition of information. It means that for performances, you actually just do draw operation, which is very fast. Encoding and decoding are very well. It's not a bottleneck anymore. It's not a bottleneck anymore compared to some other solutions. It's very transparent so here's how it works. Okay, we take the file, we get it into blocks of data, and these blocks are then encoded into more information and information. So from K data block has this 6 data block, not C parity block. And if any two of my nodes has my storage node fails, I'm able to retrieve the data. Okay, so let's talk a little about the architecture of RozoFS. There are three components in RozoFS. The first one is the metadata server, a node that manages all the information about product information and data allocation. So it receives requests from clients, meaning where should I store the data, where should I get it from. Then the storage server are this is for data. They are independent, meaning that you can use which file system you want to use. RozoFS is actually a meta file system that is on the top layer, and relying on other files from the file system. And you can provide this file system through different kind of protocols. So if you want to speak with by CIFS or IFT, it's possible. Then obviously the client is relied on Fuse, and it's the client that do the coding and decoding operation. So it's like distributing all the computation to the clients. Okay, so this is an example of a prediction use. Here at the bottom we have the backend of the system. So we have 6 nodes here that they are all storage nodes, and as well they are client, and 2 of them are the all the metadata services. One is an active one, and the other one is a passive one. It's just to replicate this server in order to have a high availability system. And well, in this platform, the idea is to provide an efficient storage system to 5 clients using they do video editing. So it's a kind of application that is very I/O intensive, and we can, by the observation, we can see that there's no problem induced by the review code, meaning that even if we do very intensive applications, there will be no problem with the configuration, with the review code. Then we have some funny applications with students in the University of France. So this project was about to test RozoFS on to test the limit of the software and try to see if it's possible to use it on a Raspberry Pi. And it was. We do applications like video streaming on it, and yes, it's fine. Okay, so thank you. Well, have a look at the GitHub webpage project. If you have any idea to share about what kind of feature you want to make, to provide in RozoFS or anything, don't hesitate to do that. Contact me at this email and have a look at the FOSDEM project, which is dealing with a rigid code comparison for distributed storage.
Hi. You said that you copy the original file to create English files. Can you select which server or machine that copy will be copied?
Oh, you mean, okay.
Let me rephrase it. I have 2 data centers. I want to I have 3 data centers, 3 groups of servers. I want to have a copy of the file in the different data centers. Can I do that?
You need to do like geo-localization of the data.
Sorry?
You need to locate the data in a batch. Well, it's not specified here in RozoFS. Yes, actually here data distribution is just done in a way to improve to balance the storage consumption in the data center. But we are experiencing multi-site things and how to improve performance. At least set some rules to distribute it in a geographical aspect.
So what kind of applications of file system would an example of you access a file from units accessing?
Oh, you mean, okay, so how many clients can we
Access file system?
Yes, that's a good question. I don't know. I don't have any number that limit the system of number of clients in access. Well, because we are really looking after some people testing the software and even following
Is there any tools like check checking the
Like monitoring tool? Yes. There's a way to repair nodes when there's a failure. When you detect that, for example, a drive is crashed, and there's a way to retrieve data, so you can. There's a mechanism to reconstruct the data.
But if it's a problem with the namespace server, if it's the RozoFS system which is affected, is it
Okay. Well, if there's a problem with the service that manages the namespace, okay, so for this case, actually we do have two of the services that are distributed in different nodes, and if one fails, we currently use pacemaker to switch the service to another one. Yes?
One more question. Do you support nodes of different size, and what algorithm do you use to choose where data should go? So if one node is larger than the other, do you store more data on that node, and how do you handle that?
Well, currently we define nodes in volumes. So each time when you consider a volume that will bring drive the same amount of same storage capacity. Then, if you want to add more nodes, when you define a new volume, for example, you bring in the same way nodes with the same volumes. So you can share. When you want to store files, you could load balance heuristic blocks in order to balance the storage coefficient in this node, this drive. So normally there's no unbalanced distribution of in a volume.
Right, we have to stop here because we're going over time. So if you have more questions for Dimitri, you can take it outside.
Okay, would be glad to.
Okay.